It's like there we go. Good morning. I'm Jason Kessler. I'm here with John. I work at NASA at headquarters, and I am the... Woo! That's what I like to hear. I run the Asteroid Grand Challenge, which we announced in 2013. It was... Hello again. So we announced this grand challenge back in 2013 because we recognized while we were doing an awesome job of finding hazardous asteroids, we felt like there was an incredible community out there that we hadn't engaged. And maybe through non-traditional partnership, incentive prizes, we might be able to accelerate that hunt. And what you see here, you may recall in February of that year, February 2013, a 17-meter asteroid exploded in the skies outside of Chelyabinsk, Russia. What was so incredible was it was early morning, and the dashboard cams were so prevalent that we got tons of footage, and it immediately streamed around the world. Additionally, you see images from building cameras and such. And unfortunately, there were about 1,000 people that ended up in the hospital. Nearly $40 million worth of damages in this city of eastern Russia. And it was February, quite cold. And what ended up putting up most of the people in the hospital was they're gazing through the windows at this bright light in the sky above them, that then the shock wave came and blew the glass out into their faces and such. And so I think in February of 13, we all recognized that the reality of our busy neighborhood was one that we needed to do something about. And that really helped spark the interest in the Grand Challenge. Here you see a map of bolide events, just to give you a sense of how busy the neighborhood we live in actually is. These are all impacts that happen in the sky. You'll see the evening sky light up. In the daytime, you can see the yellow and the various sizes of the impacts in the air. And this is all from ultrasound data that we hope to be soon opening up so we can create more interesting visualizations than this 2D map. So the Grand Challenge was an effort to engage broadly. And I found myself at a maker fair in 2013. And what you see on the top of that image is a mobile phone game that we've developed with a friend and partner that was helping support Verizon. At Maker Faire, he had hacked a Frogger game that was feeding real-time New York City traffic data into it and came by my booth and said, I want to do the same with asteroids. And you all probably have seen, if you didn't actually get to play it, the little asteroid game where we had a triangular spaceship blowing up the asteroids as they flew by. And that inspired him to want to try to help our cause. And what was so fantastic about that is that with large corporate sponsorship, Verizon getting engaged in this effort, we were able to develop a game and incorporate a citizen science component. So the screenshot that you see in the middle there of the three mobile phones is actual asteroid spectral data. So a telescope takes an image of the asteroid, it sends back the type or at least a spectral curve that is connected to the type of asteroid. And so we have the potential, once the beta is released, to engage millions and millions of citizen scientists that can use their skill and eyeballs to help us improve the algorithm for classifying the asteroids, which is really quite important, because if something is coming our way and we need to mount a mitigation mission, we need to know what it is. Is it a rubble pile? Is it a stony? Is it iron? And with this type of information that the crowd can help us gather, we can be better informed. The second really exciting program that really spawned in 2013 is the one that we're going to focus on primarily here today, and that's the ULTRASCOPE. And you can see down at the bottom there, the Asteroid Challenge Lab is our logo, and it's really this belief that opening our doors and listening to ideas that people have, we can improve on the work that we're doing. And that led exactly to the Open Space Agency's effort to build an open hardware telescope. With that, I'll turn it over to John to dig into the details.
Thanks, Jason. So the Open Space Agency was set up to help unlock the talent and insight of citizen space explorers. To do this, we identify systemic data processing bottlenecks that plague space agencies and leverage and facilitate eager amateurs to contribute to the agency's big data challenges. Project ULTRASCOPE is the first example of this, as Jason said. So, start with the inspiration for the project. The inspiration for this project was found while aiding NASA with the Asteroid Challenge Lab. We were introduced to a man called Peter Birtwistle. Peter's a man on a mission, and he has performed hundreds of asteroid follow-up observations, or light curves, in collaboration with the Minor Planet Center. These essential studies give us a good idea of the attributes of the object, for example, what it's made out of. Peter Birtwistle is the inspiration for this project because we need thousands more people like him to have any chance of characterizing the estimated million near-Earth objects that surround us. As each light curve takes on average about 6 hours to complete, this means we need a lot more telescopes and looking at the sky to deal with this workload. So, Project ULTRASCOPE. Project ULTRASCOPE aims to inspire people to become a citizen space explorer because it is an ultra-low-cost auto-robotic observatory which uses a smartphone as a CCD and for connectivity. It is Fab Lab buildable using 3D printed parts, laser cut sheet material, and bought-in components. This means it can be built all around the world. The remote control feature means that city dwellers can access a scope from anywhere in the world with the internet, anywhere in the world with the internet, and avoid light pollution issues. We like to call that armchair astronomy. The accompanying gamified astronomy web app aims to attract a new generation of Peter Birtwhistles while coaching the user through a set of ULTRASCOPE learning badges connected to NASA's Asteroid Challenge Lab. And of course, as we're at the Open Hardware Conference, all of the projects are open source and we encourage makers to hack the scope indefinitely. We believe that the best version of this scope will come from the community, and we aim to fan the flames of an endless R&D cycle using established platforms such as GitHub for electronics and code and Revolver for the mechanical side. We are also working on getting free access to our makers to a collaborative cloud-based platform so that the development cycle can be accessed as freely as possible with professional CAD tools. So as you can see on this slide, we already have 5 scopes around the world, and with more scopes, we can do some really amazing work. The ULTRASCOPE network will use Minor Planet Center data forwarded to the ULTRASCOPes in different locations. The data becomes much more credible and could help form more needed astronomy communities. So it's basically photo layering and multiple light curves mean that there's less chance for error. The final slide shows some of the great moments we've had so far. Here is an image of Jupiter and its moons that we streamed from South Africa to LA over a 4G network, mobile network. This was taken with a previous prototype with a 4-inch mirror. The current one that we're working on has a 6-inch mirror. And finally, we live in a 360 universe. A threat could come from anywhere. A big push for this project is to fill the sky gaps in other hemispheres with ultrascopes. Thanks for listening, and we'll be around all day if you've got any questions.